In this video tutorial, we are to solve question on regression. We are given the question, compute the Karl-Parsons coefficient of correlation. The Karl-Parsons coefficient of correlation is the same thing as the Parsons correlation coefficient for the given data. So how do we compute this? Solution. For more on this lesson, you need to subscribe to this channel. The first thing to do is to write the Karl-Parsons coefficient of correlation or the Parsons correlation coefficient, which is or which can be written as RSY. The Parsons correlation coefficient is equal to n summation. Since we have x and y here as the variable, we have summation of x, y minus summation of x, summation of y, all over square root of n summation of x squared minus summation of x all squared, bracket close, multiply by n summation of y squared minus summation of y all squared. So this is what we use in computing the values we'll get from this table. The next thing to do is to write out our table, is to write it out properly. Of course, we have x and we have y. So we bring down the values. We have 1, 2, and 3. Here we have 2, 3, and 4. Of course, from the Karl coefficient of correlation or the Parsons correlation coefficient of correlation, we have x squared here, we have xy, so and we also have y squared. So we impute it here, x squared, y squared, and xy. So we find these data. X squared, for we to get x squared is just to square all the values gotten here. So x squared, 1 squared is 1, 2 squared is 4, and 3 squared is 9. For y squared will square all the values that are here. So we have 2 squared to be 4, 3 squared to be 9, and 4 squared to be 16. Now we have xy, which is x multiplied by y. X multiplied by y, we have 1 multiplied by 2, which is 2. 2 multiplied by 3, which is 6. And we have 3 multiplied by 4, which is 12. So this is how we can compute this. Now we'll find the total. 1 plus 2 is 3, 3 plus 3 is 6. 7, 9. 10, 14. 14 here. 29, 20. So these are the values we got from this table. So these are the sum total for all of these variables we have gotten. So all we need, before we compute this, all we need to do is that we'll write out whatever we got here. That means summation of x is equal to 6. Summation of y is equal to 9. Summation of x squared is equal to 14. And summation of y squared is equal to 29. Then summation of xy is equal to 20, where n is equal to 1, 2, 3. N is equal to 3. So all we need to do is just to compute this. is to compute the car coefficient of correlation or the passing correlation coefficient of correlation. So we have the passing correlation coefficient of xy to be equal to, of course, we have here as n is 3 into summation of xy, just xy is 20 minus summation of x, summation of y, summation of x is 6, summation of y is 9. So we have 6 multiplied by 9 all over square root of, now we have n here, our n is 3. So we say 3 multiplied by summation of x squared 14 minus, here we have summation of x all squared, summation of x which is 6 all squared, then we have n again to be 3 into summation of y squared, summation of y squared, summation of y squared is 29 minus, now we have summation of y, just y, then all squared, that means 9 all squared. So the next thing to do is for we to use our calculator to resolve it. So we'll move over to this other side of the board so that we can now find the total of this. For more on this topic, you need to subscribe to this channel. All right, so we have 3 multiplied by 20 is 60 minus 6 multiplied by 9 is 54 all over 3 multiplied by 14 is square root of 42 minus 36 into 3 multiplied by 29 is 87 minus 81. So our car correlation coefficient is 60 minus 54, which is 6 all over square root of 42 minus 36 is 6 multiplied by 87 minus 81 is 6. So we have 6 all over square root of 36. Of course, square root of 36 is the same thing as 6. So 6 cancels 6. It then means that the car correlation coefficient for xy is equal to 1, because if 6 divides 6, we get 1. So for more on this topic, you need to subscribe to this channel. This is how we can compute the car correlation coefficient or the passing correlation coefficient.